us. Real dollar impact.
And new worlds be Veritas Automata, the truth in machine, shaping reality in every routine.
Cool. Welcome to the Veritas Automata Deep Dive. I'm Ben Savage, the CEO and founder. I've got with me Dr. Sarkar. You're going to notice today that you'll probably see some things that are not the same in our video stream. If you want to talk, Saurabh.
Yeah, we have switching cameras.
And you're going to notice probably some extra green screen in the background. We're still working through some details, but we've gone multi-camera. Yeah. So something will probably go wrong. But on that note, I've been experimenting.
Oh, wow. I know.
Yeah. I'm not even showing them what I've been using the software to build. No. There was a whole brand new music tool that came out last night.
Okay.
A-Step 1.5. So there've been a couple of libraries. There was Heart Mula, there was U, which you and I tried maybe a year ago. None of these were anywhere near what you would get with Suno or Udio or any of those commercial tools. A-Step kind of changes the game. So I'll play you a couple songs.
Right.
One was just the very first thing that I created.
All right.
And this is all AI generated. I also used ChatGPT to help me with the lyrics about an evil robot llama. I mean, all right. It's got a good sound.
Yeah.
And then I was thinking that, our theme song needs some updating.
Yeah.
I think we're going to have to do some more work. So these are just testing the tool. We're going to have to, because the way that theme song originally came up is I went through our first couple of transcripts, used an AI to help me summarize those into what are the themes that are into a song. So the version we've got now kind of sounds industrial or Devo-like.
Right.
So we'll go here. It's a little slow burn. Almost sounds like an electric slide guitar. It's kind of interesting sound.
Yeah.
It's kind of generally rock.
Yeah, it's pretty hard. I mean,
there was this one I was trying to do like an 80s. That's not the right one. Oh, never mind. That's the one I wanted. I was trying to do something a little more 80s synthwave here.
Right.
But it was okay, but
well, speaking up, pretty good.
Yeah. And then we get this one. It's going to have some same things. A little bit higher pitch than the others. So, but it shows there's some possibility here. And this is all done locally. This is all done. I did this on a 4090 and to do 2 songs at a time, it was taking 30 seconds of generation.
30 seconds, you're getting a song at that quality. And that's impressive.
On a local machine. That's a 4090. So that's what those are laptops. So those are 16 gigs of RAM because I think a desktop is 20 or 24 or something like that. So it's not a ton of video RAM to go do this. This is readily accessible, particularly in the current world of, well, you thought it was going to become affordable and now memory's way more expensive.
Okay. I got to introduce you to my kids. I'm thinking WWE entrance songs. Now they're going to play that in full blast while they enter the room. So,
I mean, there could be a way to do it. I mean, we do have a colleague. I don't know if you know this, but we have a colleague whose interview question for everybody is, what is your WWE entrance song when you go into a room?
That's interesting.
Yeah. So I mean, now this could be done on the fly.
Yeah.
Could be for good or for evil. They have to come back to this. But I think in addition to that library dropping and us playing with it, and we'll go find some more stuff. I think in our industry, one of the biggest talks in the last probably 5-7 days has been what was Claude and then Moltbot and is now OpenClaw.
Yeah, they changed the name quite a bit. I wonder who is doing that.
Well, I think they were legitimately, and I thought Anthropic handled it well. As they had a discussion, they figured out a better name. The community decided they wanted something different. I thought the naming thing made perfect sense to me.
Okay.
But the key is the tool, because you're familiar with this. It's an agent that can go control everything, and you give it the keys to your everything.
Right. I mean, that scared me from even trying that out. Maybe someday we'll spin it up in a sandbox and try that out. But yeah, it's essentially like Cloud Desktop or, the ChatGPT desktop, whatever equivalent, but with a lot more power. in that essential, right?
Or maybe the other way to phrase it was with less security and less control.
I mean, yeah, there's a trade-off: how much power you're gonna give and how much security stuff you're gonna step around, right? So, I mean, it's an interesting concept, but without the security and without the, we know how probabilistic these models are, right?
Yeah.
They can decide to wipe your disk and just say, "Oh, sorry, I did that," kind of a thing, right?
Yeah.
So there's real issues around there.
And I think it breaks down in two ways, right? Because there's a lot of people looking at how do you get agents to run for longer and do more work.
Yeah.
Now, I think both of our own experiences, the challenge is how do you make sure those agents have sufficient instruction to go execute the work, and you've got checks so that they don't wander off along the way. And I think that's part of what's happening as people are looking at OpenClaw, as they're seeing some really interesting ideas that people are trying to do. But because so much of it is vibe coded, they're seeing some security issues, both in the security of OpenClaw itself, and then also in a lot of the libraries and things. There's some very malicious ones. But then I think the other thing is, how do they make sure it's being efficient and effective in what it's doing?
Right. Yeah. So if you think about it, even today, if you go on, I'll say an LLM and ask, say, hey, I'm going to execute this, lay out the plan, and it will lay out a pretty tangible plan, right? For example, you mentioned set up a reminder, right? You are on a OS X system, you want to set a reminder on the calendar, so it knows these steps, how to do it.
We were talking about that offline, so they didn't hear that part. So one of the things in the article, and we'll share a link to this, talking about some of the security and the other issues, but they were pointing out that someone built a reminder with OpenClaw, and it was making a 75-cent use of tokens every time it called Claude.
Yeah.
It did this multiple times and burned $20 just on a reminder to go get groceries.
Yeah. So there are issues with all LLM that it goes, since it's a probabilistic model, it tends to go down sometimes in rabbit holes that it doesn't need to go down, right? So I somewhere I read on probably they burned through the entire token for that day just reading through this own documentation kind of a thing, right? So those things happen, right? So without the security piece of it, without the guardrails, a lot of these things, there's a chance you will roll the dice in a way that it goes down a path, and it's not predictable that way, right?
Well, and I think you hit on one thing too. It's like, okay, if I need to go set an agent tool or a timer or something like that, that probably is something that should be a tool locally versus an LLM call. And so I think as you look at these systems and build these agentic systems, there's a ton of cool stuff you could do, but you really have to think about, when do I need the frontier model? When can I use a smaller or a local model? When do I just need a conventional application to go run something that can go talk to an agent or go set a normal thing? So these end up becoming systems versus just I've prompted something to go do something.
So I think technically you could call it the policy network or the policy layer behind it. So given the state and given the action where you're going to go, what is the right tool to say? It could be even like a calculator or the reminder app. Or is it really something generic that LLM needs to engage, right? I think you shared a paper, I think, from Microsoft, Lightning.
So the agent Lightning. And that's continuing on agents and tools, but that's about how do you build reinforcement learning to make your agents more powerful.
Correct. So it's kind of similar to what we just talked about. What it would do is their framework is collecting the trace. Like when an agent made a decision, why it made a decision, what was the outcome, and then a reward to it, how hard it was to attain this. Was it a really convoluted 50-step process, or is it a 2-step process to achieve the same goal kind of a thing? So once you have this data, you could start to tweak the LLM with a policy layer on the top. It's not adjusting the weights. You could fine tune the LLMs at that point, but
if you look at the way Agent Lightning is installed, right? One, it's really cool because it goes in and can work with any of the existing frameworks, whether that's Crew AI or AutoGen or LangChain. So it can do that, but it does actually have a whole element of it's retraining. It's doing some recursive learning with the LLM itself.
Right.
So it is essentially doing some fine tuning. So as you go make these calls, it's got central memory that looks at all of those and then starts to go do that reinforcement loop to make it so it is going to generate a better response.
Correct. So if you think about the space it's living in, right, it's mainly around decisions the LLM's making, not the exact output, but what are the steps, what are the tool call, what was the, so essentially you could learn that policy layer that if I am in such state, by state I mean this is your data you have, and this is the current state and this is where I want to go. That's your state, right? And then the tool is your actions that you can say. There are 5 different actions you can choose, almost like a multi-banded kind of a thing. But with the reward, you can pre-select that. So you can nudge the LLM. That's one way to do it. In the context, you nudge is, hey, we prefer you use this tool, but you do have access to others. And the LLM kind of gravitates towards that. Or you could even bypass the routing wise. You could bypass the LLM and go straight up, use a tool when this state happens.
And this is in some theory, right, where MCP is supposed to fit. It's supposed to help you provide this list of tools a model can go call.
Right.
And those could be other agents, or they could be conventional tools. So it's kind of in that space. And that's interesting because I think I haven't seen anyone who's built a reward function for calling the right MCP or the most effective MCP in those. So
I mean, it can be designed very well because if you're tracing it, you're also tracing how many steps or hops you took to get to the end goal, right? And you're registering that. And if you are collecting enough data, those tasks will get repeated. And you do some dice roll, it takes a new path. That also get recorded. Now you have this data set of almost like a Markov chain kind of setup. You have a lot of different steps you're going through, which is a better strategy to achieve this kind of a thing, right?
But I think it does get to one of the things you and I've talked about a lot is it does argue for using a smaller model for your agents. So then it's easier to go train that versus, because when you work with these tools, there's always the question of, do I go use a 70B, a 400B? Do I use a frontier model, or do I use like a 1B or like some of the IBM Granite series, which are all between like 1 and 8 or something like that. If you use one of those, because if you're using that, your training cycle is going to be much faster on the smaller model than the big one.
Correct. And even on fine-tuning side of things, it would be much faster when dealing with it. Yeah.
So how would you differentiate what Agent Lightning is doing from fine-tuning?
So Agent Lightning sits a layer above it. So you are collecting a lot of actions that it has taken. And then you are also collecting the tool calls, what are the prompts it went through. So it is building that framework on top of it. You could use that to find a better path and then score it. The reward function comes into the play. Then you're choosing and then fine-tuning in the end. That way, there's no policy network. The agents themselves are designed to act on a most optimal strategy to do it. So they're two different beasts, but I think they serve the same purpose, is to optimize that, not go on spend $20 on setting a reminder kind of a setup, right? Which I think brings to the another point. I think you shared this new NVFV4, which is
So we had talked last week about quantization, and that kind of fits in this whole space, right? Which is, okay, it's not only how many billion parameters, but what is the precision that model is trained at.
Correct.
And so NVIDIA, particularly with the Blackwell series and like the Spark and some of that, has been making a lot of talk about how they can be very efficient at FP4. And they were some of the first chips that could do that.
Yeah.
And this is a paper where they were talking about how to do a enhanced distillation where you lose a lot less data than what we were seeing in the paper we were talking about last week.
So just to kind of level set what FP4 versus a full precision is. So the weights, the reward functions, or the feedback error signal that comes in, typically those are in high precision values, right?
Like FP16,
FP16, correct. So what happens is that when you have that larger number,
let's just backtrack. So when we say FP, that's floating point with 16 digits of precision.
Correct.
Basically,
and so more the digits, more the precision, you have more compute time and more energy you need, or the resources you need to train it, right? So NVIDIA came out with this new format called NVFV4. So essentially it's different from FP4 in a way that best way to think, if you're trying to measure a number, right? But you have one scale and it's only can do 16, 16 digits, I guess, right? So, and you lose a lot of precision when you are trying to do a large number versus a very small number, right? But with the NVFP4, if I'm reading their paper correctly, they have 2 scales, one a local scale and one at a larger scale. So when they take a number and they collect 16 numbers, they call it block, they apply a scale, even if whatever output's coming out. So that's your local region that they will scale. And then they create a block with that local scale. And then when they go at a tensor level, which is a collection of blocks, they apply a global scale. So, think of this, when you are dealing with very, very small number, you have a scale which are really good at measuring small numbers. So it does a good job at it. right? And when you are dealing with large numbers, they have a bigger scale, so they can slide it over and they collect the smaller numbers or similar numbers together
Yep.
in a block, right? So it's a very smart way to do it, so you don't lose precision, but you still
Well,
compress
and
it
they
down.
did a couple of interesting things. And one, the idea they did this based off of was actually from a 2018 paper about quantization aware distillation.
Yeah.
And what they did was they, to your point, they looked at it and they said, okay, how can we have the model when it's doing that distillation, do it where it doesn't lose key points of knowledge? But then they also did a reinforcement training. That was the other part I thought was really interesting. Was after they did that distillation, they took the same. So if they were doing a Nemotron 30B, and then they would do the distilled version, and they would have that do reinforcement learning from the original quantization model to make sure that it filled in some of the gaps. So yes, it's a smaller model. In theory, it can run faster, but you have a lot less loss.
Yeah. So, there are two big families of quantization process. One is quantization aware training. So, and then there's quantization aware distillation. There are two different ways of doing it. The training one is you take a full precision model and then you try to run it like a forward pass. It will assume all of the weights are quantized, so it will behave like that. But once you get the error function, you backprop it with full precision. So it learns to do that to predict in a low quantized or quantized model basis, but the training is still happening at high precision. That way you can reduce it down at inference. It's not surprised that way, right? They can reduce the error, I think, per the paper, really, really close. But what they have found that it's missing, it's shifting the distribution. And then it's unlearning some of the skills that you did and some of the reasoning. They start to unravel really, really quickly on that process.
Well, and that fits with the paper we saw the other week, right? Where like for certain programming language, it was really impactful, or just the way spacing and formatting was coming for those programming languages. And when you think about the way compression is going to work, right? What's a really common thing? Lots of spaces or lots of certain letters. So if I'm going to compress, that I start to have less of them. And if you've ever seen like an image that's been compressed too many times, you lose some of those key bits. As some people call it bit rot as it goes through.
Yep. And then the distillation it kind of reminds me of the GANs long time ago. You have a model and somebody's trying to mimic it. Distillation is kind of similar. You're trying to mimic an output of a bigger model using a smaller one. That has it supposedly per the paper, it's much better at retaining some of the skills that are the reasoning that you have taught with a full precision. So that was an interesting but very dense paper for sure, but it was an interesting way they did handle that.
So we've talked about open Claude and we've talked about agents and quantization, which leads us to RAG, or what's better than RAG, right? Because if you have your agent, it's got to go get data from somewhere, whether you call it memory or something. So what was that paper about?
So RAG, typically what you do is you have a large corpus of data, you would chunk it, you would embed it. So chunking means you're breaking that into smaller pieces. Embedding is you're taking a body of text and creating vectors out of it from the token itself, right? And then when you query it, it finds very similar embeddings or tokens, very similar to what you've asked. They don't have to be exactly same, what the meaning is same. They extract the contents out, and then the LLM has some information on which it can answer that question, because that's how you would do a RAG, a typical RAG, right? With the other paper that what was the name?
Page index, I think.
Yes. So what they did, they bypassed the whole chunking and embedding and all of that stuff. So once they ingest a paper, they create almost like a table of contents kind of a thing. How does the document fit in the overarching picture? So almost like a human.
They basically turn it into a graph.
Yes, it's a graph-based system. There's also graph in RAG, but it's slightly different or quite a bit different than how they applied. They're putting the documents in a systematic graph manner, so that when agents are looking for information, they can navigate that. So for example, you want to learn about a question on quantum physics. So you go down the physics, then quantum physics, and then so on and so forth, and then retrieve that entire document, which is relevant as he's navigating through this setup, right? So that was interesting because it completely bypasses the RAG. Now you can have a very, very large corpus without having to worry about vector store and all that stuff. But graph RAG was where you have concepts linked together using semantics, right?
And the challenge there is that would span multiple documents, whereas this is a graph for each specific document
Correct.
so that as you're going through, you're maintaining relationships better is the argument.
Correct. And you can navigate upwards and pull another document where if you think if a typical example would be your one document is referring to something else, another document, it should be able to navigate back and pull it out and then have both the documents read through it. So it was an interesting concept. I think it's on GitHub so that people can run on it.
We'll provide links to all of this when we put the show notes in.
Yeah, that was quite a new approach of retrieving information without fine tuning or retraining the model for sure. Yeah,
and I think that's always going to be the challenge, right? When we were talking about like the Agent Lightning, the fact it is doing some retraining of the models is interesting, but there's a cost both in time and compute to go do that. So some of these solutions that allow you to do less of that than even fine tuning or other things can provide you other business benefits depending on what you're trying to solve. So again, these are all tools, right? There's no one best or one ultimate solution for these.
Yeah, true.
So what else have you been looking at recently in this stuff? I know you've been doing some actual work with agents. Have you found anything surprising?
So one thing that's kind of emerging, or at least what I'm realizing, maybe people have realized before, I was thinking agents as quite governed by context, right? How you specify this one is an astrophysics guy, or this one is a biologist, or something, the experiment you are doing, right? What I figured out is that they're, essentially you are making a tool call with a different context. But the agents, I think it becomes more powerful when you also provide them tools and reasoning along with it, so that it becomes multi-step process.
So when you say tools, what would be a good example?
So think of you're building an agent to do some research on finding something, right? So maybe it's an endpoint that you're looking for, and then you give it a tool like a Google search API. It can do a Google search. You can give it a curl. You can give it a tool that it can write Python, run it in a sandbox environment. So now it has a bunch of other tools stacked up. So that becomes more powerful than just saying, here's my input data, here's the context, process it. So what I found is that when it starts to engage those tools and be more generic in that process, kind of like coding agents. If you are familiar with any of those cloud ones, they are doing the same thing, but it has a lot of smaller specialized tools and whatever you call it, agents even, that is interpreting a website that it curled and downloaded it and then trying to debug it. That becomes more and more more powerful than just changing the prompt and calling it an agent that way. So
no, I think that makes a lot of sense. And even when you talk about the coding agents, right? And we're getting ready to do an experiment. I've kind of been testing Amazon Kiro, and I got access to IBM Bob, which is their tool, and I've got Anti-Gravity and then Claude Code, and I think I've got a Cursor account somewhere. And they all take different approaches to the way they define spec, which is one type of agent and one set of tools, or planning, and then how they go build. And understanding both what tools they have and starting to get a feel for how that particular agent works through problems. You have to learn how to go apply it differently, right? Because it doesn't always give the response you expect.
Yeah, I mean, this agentic stuff gets more and more powerful as you start to overlay a supervisor on top of it. I'm not talking about like a LangChain or Crew AI where everybody is talking to the same AI with a different context and with the history of the chat, right? There is a way to enforce that. Hey, you got to go through this playbook of doing this stuff, right? And as it sees things which are not aligned with what is expected, then you generalize and figure out how to solve that problem.
Yeah, it's with some of the agentic stuff, you're combining all the challenges of computer science and algorithm and how do you define a problem and a domain for a program to go work with some things that are different, but in some ways more similar to human management in that how do you double check a task because you're not getting consistency, so you can't build an automated test. I think I was talking with you about some of the agentic work I was doing. One of the problems that I found is just, and again, I'm doing this on hard mode because why would I take the easy path? And that because I'm doing this with local models with Olama, they don't always respond consistently with JSON, or when they respond, their markdown text will break JSON messages.
Mhm.
That creates a big problem for the rest of your program, because now, okay, it sent a command, it got a response, but now it breaks the response. So then you have to have a JSON cleanup library.
Yeah.
But you can't have a fixed thing, because every time you do it, it finds a new edge case. So now you end up in this continuous loop of fixing that. So now you've got to find something that is almost agentic based to go fix the JSON.
Yes.
And you're just like,
yeah.
And there's a certain point where you go, maybe I should just write 3 lines of code and do this another way.
Yeah, I think one of the problems with agentic stuff, or any of those autonomous agents, whether it's a coding agent or otherwise, is the source of truth, right? So because the context gets filled very, very quickly. Let's say you're doing a coding agent and it's writing lots of thousands of lines of code, and it has forgotten by the time what was your initial instructions, right? So having this architecture where there's a source of truth, it can go refer, and it's within the instruction itself that as soon as you complete it, go update that somewhere else, or look at what was the original spec.
Well, and that's where you see like the agentsmd file. And there's a couple of other files that you're seeing more and more the tools settle on, where you can go, whether it's an architecture or agentsmd, that it drives that to become source of truth for its decisions.
Yeah, I think my experience with coding agents, that it tends to simplify when he meets a hard problem, just to get to that objective function.
I'm laughing because I had it build something the other day.
Yeah.
I did an agentic thing, and it gets all the way done with the build. I'm like, that seems like a suspiciously low number of tokens for what it did.
Yeah.
And then I'm working through and trying to run the program, and it goes, oh, I just did that section as to do. It was the core of what the logic, what the program was supposed to do.
Yeah.
And it just put to do placeholders in the code. You're like,
yeah,
I think you missed the point here.
Yeah, exactly. So I think leaving them alone and just vibe coding, it is in theory, it's a great idea, but I think it needs a little bit more guardrailing around it to stick to the truth kind of a thing.
It does. It gets to a lot of the requirements. But then the other thing is, if you're just vibe coding on your own, and it's just for one person, you're probably maybe okay.
Yeah.
I'm not going to say anything than probably maybe okay. I'm being deliberately very loose in that, because there's a lot of times where it just builds code that's very brittle and breaks on error, on different error scenarios, or it's just a little wonky the way it works. If you're going to build something where it's going to really be used, you're going to have to go through a more conventional review process. If you don't code, you're going to have to go find some way to get the code reviewed, because 1, security, and 2, it's going to have reliability. And just the number of times I've watched vibe coding tools, you're going through and it's just ignoring all the warnings, but it's like, or even ignoring errors. It goes, this is a hard error to go fix. I'm going to go skip it. You're like, you're supposed to fix it so it works, because you just broke the whole app.
Yeah, it's agentic stuff. I think it's where a lot of this automation will head, but also a lot of tooling needs to be built around keeping it truthful and not simplify and not forget the requirements.
Yeah, no, I think that's a good closing note for the day. So we thank everyone who's joined us. Again, this is the Veritas Automata Deep Dive. Please like, subscribe, send us questions on social media or on LinkedIn or wherever you find us. We do want to hear what people want to hear more of or what they hear less of. I'll remember to continue eventually doing this tag in the beginning as well. You are going to see our camera solution continuing to evolve. So forgive us for that for today, and we'll keep on going. So thanks all.